Hi, welcome to section 4.5, multiplication of polynomials. So here we're going to cover distribution of monomial. Monomial means one term. So if you take a look in this example, in front of the parenthesis, the open parenthesis, we have negative 8k to the third power. That is a monomial term, meaning one term. So one term, or a term, can have a number, it can have a variable, or it could have a combination of a number and a variable. In the parenthesis, we have two terms. The first one is negative 5k, and then the last term is just 1. As I mentioned before, a term can have just a number, it can be a variable, or it could be a number with a variable. But in here, we're just going to focus on distribution of monomial. So that means that we're going to distribute negative 8k to the third power to whatever we have inside the parenthesis. Now before we begin, just remember that when you have a variable by itself like this but no visible exponent, it's just going to be an invisible 1. So as I stated before, if you don't have any visible exponent on the variable, it just means an invisible 1. Alright, we're going to distribute negative 8k to the third power to the first term, which is negative 5k to the 1 power. So we're going to multiply. That's what I mean by distribution or distributing. We're going to multiply. So when I multiply, we're just going to multiply the numbers, the coefficient. So by coefficient, I'm referring to negative 8 and negative 5. So I'm going to multiply them together. So negative 8 times negative 5 would be a positive 40. And then when we multiply with the k together, we still have to remember the laws of exponents from section 4.1. When we're multiplying same base, we're going to add the exponent. So I'm going to write out the steps. Here's my work, k to the power of 3 plus 1. Then, after I multiply, I distribute to the first term. I'm going to distribute the same term, negative 8k to the third, to the last term inside the parenthesis. So I'm going to distribute negative 8k to the third to this one, as illustrated by my purple arrow. Now, since I'm multiplying to a number, there's no work needed for the exponent. You only need to show work when you're having a variable times a variable. In this case, k times k, which is why here I have k to the power of 3 plus 1. But if you're multiplying to just a number, there's no work needed for the exponents. So I'm going to multiply 1, negative 8, or in this case a negative number times a positive will be negative. So here's my minus for the negative. Then I'm just going to multiply, and I'm going to get minus 8k to the third power. So after I finish distributing negative 8k to the third to everything inside the parenthesis, I'm going to simplify my exponents on the first term. So I'm just going to do 3 plus 1. So now it's going to be 40k to the fourth power minus 8k to the third power. Since these two terms are different, I can't combine them, so I'm going to just leave it like this, and I'm going to box it as my final answer. So for this example, my final answer is 40k to the fourth minus 8k to the third. Be extra careful with your signs when you're multiplying. Be careful with your work for the exponents. So let's take a look at the next example. Negative 3p to the sixth power is going to be multiplying to my expression negative 3p plus 5. So I'm just going to repeat the same process as I did in the previous example. I'm going to distribute negative 3p to the sixth to the first term, in this case negative 3p. But remember, I have this p with no visible exponent, so that means it's going to be an invisible 1. So I marked it, so I made it a visible 1, so just make sure you remember that. So I'm going to distribute negative 3p to the sixth power to negative 3p to the 1 power. So just like before, I'm going to multiply my coefficient. Negative 3 times negative 3, that would be a positive 9. In addition, for my p, I'm going to have to work, when I'm multiplying together, we're going to add the exponent, so 6 plus 1. So after that, I'm going to distribute negative 3p to the sixth power to the last term inside, which is, in this case, 5. So as indicated by the purple arrow, I'm going to multiply, and as I stated before, if you're multiplying to a number, you don't have to show work for the exponent. So my negative term multiplied to the positive term, that's going to be a negative. So I'm going to put the minus first. Make sure I have the right sign. Now I'm just going to multiply. So 3p to the 6 times 5, that's simply going to be 15p to the 6. So after I finish distributing to everything that's inside the parenthesis, I'm going to simplify the exponent here on the 9p. So 6 plus 1, that's going to be 7. So that's going to make 9p to the 7th power minus 15p to the 6th power. Since these two terms are different, meaning different exponents, I cannot combine them like terms. So I'm going to leave it like this, and this will be my final answer. So for this example, my final answer is 9p to the 7th power minus 15p to the 6th power. So again, as I stated before, be careful with your signs when you're multiplying. Check if you have the right exponents, and you do have common terms. Make sure that you combine them, whether it's adding, subtracting, depending on their signs.